This video we're going to talk about patterns and sequences, and so we're going to discuss how to determine sequences or patterns that you might see on the test. I'm not going to go through how you write them out mathematically or anything like that. That I think is something that's beyond the GED test. So I'm just going to teach you enough so that you should be able to get these questions right on the GED test. There is additional information regarding sequences that you should know if you're going to continue doing math. But for the GED test, I'm going to try and keep it at the simplest level so that you can answer the questions that I would expect you would see on the test. So there are a couple of sequence patterns that we're going to learn. The first is called arithmetic, and that is when you add or subtract the same number to each element in order to get the next element. The other sequence is called geometric, where you're going to multiply or divide by the same number to get the next element. And the third thing I want you to just be aware of is sometimes they might just be squaring the numbers to get each element in the sequence. So what do I mean by this? We're going to start out with the arithmetic sequence pattern. And so let's say we had this sequence. And the question is, what is the next number in this sequence? And so the first thing that you want to look at is it arithmetic? So how did we get from 100 to 107? We added 7. How did you get from 107 to 114? We added 7. How did you get from 114 to 121? You added 7. So you can see that they're adding 7 to each number to get the next number. Adding 7 to that to get the next number. Adding 7 to that to get the next number. So we're simply going to add 7 to get the next number. And so the answer to this question would be 128. So the first thing you want to check for is this sequence arithmetic? Another example. Let's say they give us this. What's the next number in the sequence? First thing to check, is it arithmetic? So how did we go from -5 to -3? You added 2. -3 to -1, you added 2. -1 to +1, you add 2. 1 to 3, you add 2. 3 to 5, you add 2. So you're always adding 2. That makes it an arithmetic sequence. So to get the next number in the sequence, we're going to add 2. 5 plus 2 is 7. So that's the answer to this question. Now, it can be add or subtract, or if you just want to say add, you can add a negative number. That's the same as subtracting. So let's say this is the sequence, 9, 7, 5, 3. What's the next number in the sequence? Well, we'll first check if it's arithmetic. How'd you get from 9 to 7? We subtracted 2. 7 to 5, you subtract 2. 5 to 3, you subtract 2. So they're always subtracting the same number, so it's arithmetic. So you simply, 3 minus 2, the next number in the sequence would be 1. So the first thing you always want to check is it arithmetic? Are they just adding the same number or subtracting the same number from each element to get the next element? The second sequence, if that's not the case, the second type of sequence you'd want to check for is it geometric? Are they multiplying or dividing by the same number to get the next number? For example, 3, 12, 48. What's the next number? So you can see here, if we tried, we would always first try the arithmetic. Well, 3, so they're adding 9, but then, oh, here they're adding 36. So that's not the same. So it's not arithmetic, because arithmetic you have to be adding the same number. So we're not going to look at that. We're going to check and see, is it geometric? Or are they multiplying by the same number? To go from 3 to 12, you're multiplying by 4. To go from 12 to 48, you're multiplying by 4. That is the same number. So the next sequence would be 48 times 4. You can plug that into your calculator, and you get 192. So that would be the answer to this question. This is a geometric sequence where they're multiplying each number by the same number, in this case 4, to get the next number in the sequence. 3 times 4 is 12, 12 times 4 is 48, 48 times 4 would be 192. Similarly, you can do that with divide, or if you want to think of it as multiplying by a fraction. So for example, if we had 20, 10, 5, what would the next number in the sequence be? Well, again, if you were trying to first look at this, you would think arithmetic. Well, this would be minus 10 to get there, minus 5. Oh, well, we're not going to look at that for now. We're going to see if it's geometric. Okay, how do you get from 20 to 10? You can, however your brain works better, you can say you either divide by 2 or you multiply by 1/2. It's the same thing. So we divided by 2 and got 10. How did we get from 10 to 5? Well, you divide by 2 or multiply by 1/2. Okay, so this is the same. We did the same thing in order to get the next number of the sequence, so it's geometric. So how are we going to get the next number? Well, we're going to do the same thing. We're going to divide by 2 or multiply by 1/2. So 5 divided by 2, 2.5. So that's a geometric sequence. The other sequence I want you just to be aware of is this, where they might just simply be squaring the numbers. So I want you to be able to look out for that. So if you got something like this, well, the first thing you would do is it arithmetic? Okay, well, we added 3 here. We added 5 here, so no, it's not arithmetic. Is it geometric? Well, to go from 1 to 4, you'd multiply by 4. To go from 4 to 9, well, you're not multiplying by 4, so it's not that. Are they squaring the numbers? Well, this is 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So all they're doing is taking 1, 2, 3, 4, 5 and squaring it to get the next number in the sequence. So the next one would be 6 squared, or 36. So just be aware that they might have this type of a sequence where they're squaring the numbers to get the number in the sequence. So if they're arithmetic, geometric, or square, that's pretty straightforward. But sometimes they won't be that straightforward, and you're going to have to look for the pattern. And for these, you're just going to have to try and think logically. Let's say you have this, 1, 3, 6, 10. What's the next number in the sequence? Well, first thing we're always going to do is it arithmetic? Well, here we added 2, here we added 3, so it's not arithmetic. Is it geometric? Well, you multiply by 3 to go from 1 to 3, but then you just multiply by 2 to go from 3 to 6. So no, it's not geometric. They're not squaring the numbers, because squaring will always essentially give you the same sequence. So now what's going on? So we ruled these out, so now we're going to go back and look at this sequence. Here we added 2, then we added 3, then we added 4. So that's kind of a pattern there. We're adding 2, then we're adding 3, then we're adding 4. So the next number we would add 5. And so the answer to this question would be 15. So it's not any of these defined sequences. You just have to look at is there a pattern to what they're doing and think logically. But use this information in order to come up with the pattern. Let's do another one. We had 1, 2, 6, 24. What's the next number in the sequence? Well, first, always do this first, because if they're arithmetic or geometric or square, those are going to be easy problems. So always wonder if that's what they're doing. Well, 1 to 2, they're adding 1. 2 to 6, they're adding 4. So it's not arithmetic. Is it geometric? 1 to 2, you multiply by 2, but 2 to 6, you're multiplying by 3. So it's not geometric. It's not squaring each number. Okay, so we're going to kind of go back. First, we'll look at the addition. So here we added 1, here we added 4, here we're adding, what is that, 18? So there's no real pattern in what they're adding, let's look at multiplication. They multiplied by 2, multiplied by 3, 6 multiplied by 4 to get 24. So now there is a pattern in the multiplication line. So first we multiplied by 2 to go from 1 to 2, then we multiplied by 3 to go from 2 to 6, then we multiplied by 4 to go from 6 to 24. So this is a pattern, and so to get the next number we're going to multiply by 5. You can plug that into your calculator and you would get 120. So again, if it's not one of these sequences, then you have to start looking for patterns either in the addition, subtraction, or in the multiplication, division arenas. Let's do another one. 5, 7, 11, 17, 25. What's the next number in the sequence? Again, look at arithmetic. Here we're adding 2, here we're adding 4. Well, it's not the same number, so it's not arithmetic. Is it geometric? Well, to go from 5 to 7, that's some crazy number, 1 point something, and here's 1 point something. So geometric, just offhand, just doesn't seem feasible. They're not going to have some sort of complicated thing that you're going to multiply by them. And squaring, that they're not squaring the numbers to get them. So let's continue with this. We know it's not arithmetic, but let's look at what they're doing. To go from 11 to 17, we added 6. To go from 17 to 25, we added 8. So it's not arithmetic, but look, there's a pattern. Plus 2, 4, 6, 8. So what's the logical next number? Add 10. So here we got from 17 to 25 by adding 8. So to go from 25 to the next number, we're going to add 10. And the answer would be 35. So again, look at these things, but if they don't fit into that, start looking for a pattern on what the numbers are doing, either adding and subtracting or multiplying, dividing, and you'll be able to figure it out, but you have to use your head. I'm going to show you one more thing that's actually a very challenging question, and I hope that it's not on the test, but I want to show it to you just so you can see it, and maybe it will be in the back of your mind. I think the ones that we've seen already are going to be the types of questions that you see, but I want to show this one to you just in case. So here we have what's the next number in the sequence. Again, we always start out, is it arithmetic? Here we're adding 2, here we're adding 4. Well, it's not arithmetic because we're not adding the same number, we're adding different numbers. Is it geometric? Well, here we're multiplying by 1.5, here by something else, so now it's not geometric. They're not squaring each number. So we're going to go back to this one and see if we can see a pattern. Here we are adding 2, here we're adding 4. To go from 10 to 16, we're adding 6. Looks like a pattern, but oh man, now to go from 16 to 26, we're adding 10. Then to go from 26 to 42, we're adding, what is that, 18? No, 16? So it's not really a pattern. We would like this to say 2, 4, 6, 8, 10, and then we would know the next one would be 12, but this is kind of, it starts out good, but then it kind of goes awry. So again, I hope you don't see this on the test, but I want to show you what they're doing here is they're taking two numbers, adding them together to get the third. So they took 4 plus 6 and they got 10. They took 6 plus 10 and they got 16. They took 10 plus 16 and they got 26. And they took 16 plus 26 and they got 42. So they took the two previous numbers, added them together, and got the third number. Take the two previous numbers, add them together, get the next number. So for this one, we would add the two previous numbers, 26 plus 42 to get this answer, which would be 68. That's a pretty complicated sequence to be able to see that, but keep it in the back of your mind just in case. Most of them I think you're going to be able to answer if you remember arithmetic, geometric, and then if they don't fit into those, look for patterns.